Hello, and thank you all for joining us in the first of a webinar series on getting started in IoT experimentation with Electric Imp and Azure Databricks. My name is Gary Nakanalua. I'm the Managing Director of Experimentation and Invention here at Blueprint Technologies. We are a nationwide technology solutions firm that specializes in helping companies accelerate their success through digital transformation. Now, this webinar is part of the Azure Databricks IoT Challenge we originally presented at the Blueprint, Databricks, and Microsoft Retail Hackathon last month. So each of the participants in that hackathon was given an ImpExplorer kit from Electric Imp, which we'll be covering shortly in this webinar. So for those that are interested in participating, which I highly recommend in the challenge, we'll be sharing the first stage actually in this webinar. So for me, it's my pleasure to introduce Terrence Barr. He's the head of solutions engineering at Electric Imp. And we've leveraged their products for a number of IoT experiments in our lab. So he'll be sharing how to get started with IoT development with Electric Imp. And so with that, I hand it over to Terrence.
Thanks, Gary. Good morning, everyone. So I'm Terrence Barr. I work for Electric Imp. Electric Imp is a edge to enterprise IoT connectivity company. We make it easy for customers and partners like Blueprint to ingest IoT data into their platforms. And so I'll be running you through this webinar to give you an introduction into Electric Imp and the ImpExplorer kit and how you can get started with that and then proceed into the Blueprint Databricks challenge. So let me bring up my slides. So a little bit about myself. As Gary said, I head up solutions engineering. So I have a team of engineers responsible for working with customers and partners on the technical side, working on the solutions, the architectures, understanding the requirements, and at the end of the day, making sure that the customer and partner is successful in their IoT solution. My background is embedded software engineering. I've done several large-scale IoT projects. I was involved in a telematics project with one of the world's largest car companies, doing a connected vehicle project that is shipping into millions of cars. I also headed up the technology around the Java embedded platform at Oracle. So I've been involved in the IoT space for a number of years. With that, brief introduction into the challenge. So if you look at IoT, in two buckets, obviously data is where the value lives, where the business application lives, where the customer derives the business value, be it the predictive analytics, the monitoring, the control. But really a prerequisite to enable that business value is getting clean, trusted, reliable data from your IoT sources in the field, your devices, into that data platform, into that application platform in the first place. So connectivity is a critical factor. It's something people underestimate in terms of complexity and security. But that's really what Electric Imp focuses on, is providing that connectivity platform that enables customers to derive business value in the data and application side. So IoT connectivity at scale is a challenge. It requires a number of different areas of expertise. It's quite time intensive to integrate everything together. It can be a protracted project to implement and roll out and deploy. And it's organizationally quite challenging because you need to be able to support devices in the field for many years to come, support their operations, support the security. So all these different aspects, from hardware design, firmware design, hard and software integration, edge to cloud security, provisioning and management, and being able to scale all of that to potentially millions of devices is a challenge, and many companies get stuck trying to build that themselves. And at the end of the day, it's not really a differentiator for most companies anyway. They just need that reliable, trusted connectivity to work and deliver data into the cloud, but it doesn't really add any business value. So it doesn't make sense for most people to try and build this themselves. Instead, they would use an external vendor like Electric Imp to provide that functionality so they can focus on their business value and the data in the cloud. That's where Electric Imp comes in. Electric Imp was specifically founded to solve this problem. And we really see ourselves as the leader in this industry. We have proven IoT deployments at scale. We have more than 1.5 million devices on our platform, primarily around Wi-Fi and Ethernet connectivity. We are also coming out with cellular connectivity this quarter. We process about 20 billion messages a month for our customers through our cloud and through our infrastructure. And we have a number of customers around the world. One of the things that differentiates us is the fact that we support the full life cycle of the device, from proof of concept through manufacturing, through deployment, and ongoing maintenance in the field. And we've built the entire platform around security. And security meaning from the device silicon, from the module in the device, all the way into the cloud and all the layers in between, to be able to guarantee a security model that has no weak links and that can be supported for many years to come. We are the first and only IoT platform that is UL 2900-2-2 cybersecurity certified. If you're not familiar with that, Underwriter Laboratories has this new standard for cybersecurity for industrial controls, and we worked very closely with them to have our platform certified. We've also gone through pen testing and security reviews with a number of public companies like Pitney Bowes and General Electric. And then sort of the third highlight of our platform is that we, because the customer gets a full platform that's fully integrated and pretty much provides 90% of what the customer needs out of the box, customers tend to go from concept to production very quickly. So in the example of GE, they had a non-connected air conditioner, and they went from concept idea of connecting this air conditioner and providing connectivity to the customer to a shipping product with us in 5 months. So very fast prototype to production. To take a step back where we sit and look at this from a slightly different angle, at the end of the day, Electric Imp is really an IoT application enablement platform. So we sit between the customer's product hardware and the device in the field at the bottom and their application and data in the cloud. We provide that horizontal connectivity layer in the middle. And so some of our customers here are Pitney Bowes. They do connected postage meters with us. Eaton, we're working on a project with them for smart breakers and edge grid control at the edge. AB InBev and Budweiser, we did a connected beer fridge with them. And Petasense is in the business of industrial vibration monitoring and predictive maintenance for industrial machines, rotating equipment. So all of these customers use the exact same horizontal Electric Imp platform and the same features in terms of connectivity and security and device management and scalability, but they all build their own data and application platforms on top. Here is a high-level architectural overview. There's a lot more detail that we can provide if you're interested, but in the interest of time, I'll just keep it brief. The platform, again, is end-to-end, so it starts with what we call the Imp-authorized hardware, which is in the device of the customer or is attached as a retrofit to the device through a service port. It's essentially just an off-the-shelf microcontroller with connectivity built in. But what makes it different is that when you power it on, it's already pre-installed with our software and our keys. So it automatically identifies to our cloud, runs a secure enrollment cycle, and establishes a secure connected link to the cloud. That authorized hardware module also runs the customer's application, and we'll see that later when we go talk about the challenge. The customer's application implements whatever business logic the customer requires for their particular use case. Our platform establishes essentially a secure IP tunnel to the cloud that we manage as part of our service. And in what's called the Imp Cloud, we monitor the security, we maintain device connectivity, we do things like device management, and the customer can then run the second part of their business logic in the cloud as well. So it's kind of a distributed application model. The benefit being that the customer can implement integration and heavyweight processing logic in the Imp Cloud, and we scale it for the customer. The data then essentially flows over downstream to the customer's cloud to the left. In this case, Microsoft Azure, we have integrations with other cloud services as well. And that's where the actual business application for the customer happens. So again, we're really just a conduit. I describe us as a secure managed pipe between the customer's device and their cloud application. And we manage that link, and we make sure it stays connected and the device is secure. As part of our platform, in terms of the full lifecycle support, we also have connected manufacturing. So we have a process that includes a device called the Imp Factory that allows you to securely build devices in a factory at scale. This is something that's very important when you're going to actual volume production. Secure manufacturing at scale is a significant challenge that you need to solve, and it's solved as part of our service. With that, let's briefly talk about how to develop with Electric Imp and how to integrate it with your product, and in this case, with the Blueprint Challenge. So we have extensive technical resources. There's what's called the Electric Imp Developer Center. And by the way, all of these links are available on a GitHub page as well. So we've collected all the links, so you can go back after the webinar and refer to those. The Electric Imp Developer Center has comprehensive documentation on all aspects of the platform, including the tools, the APIs, the functionality you have available in the device and in the cloud, hardware specifications, troubleshooting, what have you. So everything is there to allow you to go off and experiment and build your own solution. The device you'll be using is the ImpExplorer. So this is one of our developer kits. Most of our modules that we provide to customers are actually small silicon modules, so SMT modules that you put down directly onto your PCB. With the ImpExplorer, we've wrapped that into a nice developer kit that has a number of features that you can use out of the box. So it runs a Cortex-M3 processor. It has 2.4 gigahertz Wi-Fi connectivity. It provides a number of onboard sensors, so temperature and humidity, motion and acceleration, air pressure. You have a RGB LED that you can control from your application. At the bottom, you see a row of connectors. Those are Grove, Seed Studio Grove connectors. So you can buy off-the-shelf actuators and sensors from Seed Studio, plug those in. On the back of the device, which you can't see here, it has a battery holder for 3 AA batteries. So you can run the device off a battery. And in fact, that's going to be part of the challenge. The Electric Imp platform supports power-efficient operation through APIs. So part of the challenge will be to optimize your application to be battery-powered and run for months off a battery. And then, of course, the ImpExplorer is fully integrated with the Electric Imp Cloud and the whole development environment and software provisioning environment, and everything comes with that. We have a very nice getting started guide. Again, the link is here. This is the first screenshot of that getting started guide. Within a couple minutes, half an hour at the max, you'll have the device connected. You'll be running your first code. You'll have an end-to-end IoT, starting point of an IoT project set up. When you create a developer account with Electric Imp, those are free. You go to the Imp Central API here, impcentral.electricimp.com. You create a developer account. You connect your device. I hesitated because what we use is a technology called BlinkUp, and you'll see that in the Getting Started guide. BlinkUp is essentially an optical provisioning method that allows you to very easily use your smartphone to provision the network credentials and a one-time security token to the ImpExplorer, and the ImpExplorer then turns around and connects to your local Wi-Fi network and securely enrolls with the cloud. It's a very neat commissioning process. So once you've got that set up, you will get to the IDE window, which you see here. And this is a bit different from what you would typically expect in an IDE. So I'll walk through some of the components because it's important to understand the different things and how they relate to the development process. So first of all, the two windows, or the two screens in the middle here, on the left is agent code, and on the right is device code. So when you develop your application, you write the device code in a scripting language called Squirrel. It's very similar to JavaScript and Node.js. You write that application code on the right side into that window, and that gets executed, provisioned, and executed by our system directly on your device, on the ImpExplorer. So that's where you can create local device code, local business logic, reading sensors, creating temperature alerts, and things like that. On the left side, you see the agent code window, which represents the code that you're running in the cloud. And there's a one-to-one relationship between the two. So for every device that's in the field running your device code on the right, there is an agent in the cloud that runs the kind of the cloud virtualized device code. So it's attached directly to the device, but you can partition your code. You can run code that you want to run in the cloud that does cloud-to-cloud integration, that does heavyweight processing. You can do all of that on the left. And our system maintains an implicit connectivity link between these two windows, which is how you send data between the device and the cloud. And once you play with some examples, you'll see how easy it is. It's a one-call API. You create a JavaScript object. You say, send to the agent, and we marshal it across the connection, and it pops out on the agent code for processing. The agent code is also where you would then push your code onwards to your Microsoft Azure service like Databricks. Build and run is up on the left. So once you enter code, this button will become live. And when you hit that button, what happens is our application platform service takes the code from the agent and the device from your IDE, compiles it, and then provisions it into the cloud and into the device, and automatically restarts it. So within a few seconds, this process typically only takes 2 seconds, you have the latest version of your device and agent code running. So it's a very nice iterative development process. Other things you'll see here is every device has a unique device ID. So if you go down, there's a device ID window. That device ID is automatically established by our system and is used to identify the device. There is an agent, a unique agent URL. So every agent is reachable under this URL, and you can actually expose your own REST APIs in the agent if you want it to be accessible from the cloud. When you're doing development, you automatically get this remote logging window. So all the messages from the agent and the device can be logged here for debugging purposes. On the left, you have various methods of device control. So you can assign devices to device groups. You can restart them with certain conditions. So it gives you control over device execution. And then finally, on the left side, there's a an icon called device groups that allows you to create device groups. For example, you could create a beta group or a group based on a location, for example. And that allows you to use our system to monitor and manage and provision code to subgroups of your device population. So let's talk a little bit about the Squirrel language, because that's what you're going to use. So again, as I said before, it's a high-level scripting language. Anybody who's done JavaScript or Node or Java or C, for that matter, I think can easily adapt to Squirrel. It's kind of optimized. It's JavaScript, but optimized for the purposes of IoT. It's very efficient. It's a small language that you can run on the device and in the cloud at scale. It has all the usual attributes. It's high level, does automatic memory management and things like that. So you don't have to worry about these platform specifics. It's object oriented. It's completely event driven, which is great for physical interactions with devices. The Imp OS, the underlying OS that we manage, allows you to take care of power management and things like that automatically. So it just offloads a whole bunch of things that the developer would otherwise have to worry about to the system. And one really nice attribute is that the applications you write are hardware independent. So they port and easily scale across the different modules that we offer. Wi-Fi, Ethernet, cellular, they port easily across these different modules. So you can address different connectivity options and different price points using the same application, which makes your life and your management of your code much easier. There are a number of useful references here, so you can go and have a look at those. So let's get to the challenge. The first step is this smart refrigerator monitoring example, and you can just walk through this. This is on GitHub. So you'll see the ImpExplorer down at the bottom. You run your code in there. You access the temperature and humidity sensor, and you push it up through the Imp Cloud into Azure IoT Hub, where you can then process the data further. You should be able to do this example in less than half an hour, and that gets you some code up and running, gives you an idea of how the APIs work, and then you can continue with the challenge from there. So looking at the different steps of the challenge, as I said, part one is this getting started, step-by-step smart refrigerator. So that'll allow you to receive your data in the cloud, have the device connected, and just get started very easily because everything's taken care of and you just follow the instructions. Part two then is, this is where you start adding some of your own code and understanding how the platform works. So adding some local processing, because you are executing your device code directly on the device, you can do local processing. So let's say you want to create a temperature alert if the temperature locally exceeds 80 degrees Fahrenheit, and push that alert to IoT Hub for processing. So that's part two of the challenge. That's pretty straightforward. Once you figure out how the Squirrel language works and how to create an if statement, right, this shouldn't take a lot of time. Part three, battery operation. So that's really a strength of the platform, is that optimized power consumption just comes with the platform. There's an API that allows you to optimize power usage. So you can do things, for example, like set the Wi-Fi communication, the Wi-Fi module, into a power save mode, which makes it turn off whenever it's not in use, and then automatically come back on when you want to send something. So that's one way you could monitor this. There are other mechanisms. You can actually put the device to sleep and wake it up to optimize power consumption even further. So that's something you can play with the API. And along with that, you can also monitor the battery level and create an alert if the voltage drops below a certain level. So that's similar to part two. Once you've done all that, you're in pretty good shape. You should understand how the platform works. be familiar with the development process. So part 4 is then interacting with a Blueprint API. So in the agent code, you can create a REST call, and you can push your device ID to the Blueprint endpoint, and the response will include an unlock code that you then use to move to the second stage of the challenge. Again, all of these details and all of the links are on this GitHub page. Once you've completed this and you understand how the platform works, there are a number of things you can do beyond this. You can extend the refrigeration monitoring system with a number of interesting features. You can add your own sensors and actuators. And then there's a whole lot of technical information, samples, libraries, more hardware to explore on the Electric Imp website. So for example, we have a number of hardware drivers. So popular sensors and actuators, for example, the Seed Studio products. We have ready-made Squirrel level drivers that you just drag and drop into the device code, and that gives you access to additional sensors. So that's something you can then explore and turn it into a more robust and elaborate application. So with that, I think I'll turn it back to Gary, and I think we have time for a few more questions.
Yeah, absolutely. So one, thank you very much for that, Terrence. That was awesome. And a theme you all may have heard is how easy it is to get started with the Electric Imp platform. So that's awesome. Really quick, just wanted to take a minute to share with you all a couple things. This here is a look at the ImpExplorer dev kit. We went through the challenge that we're presenting out there. So here you can see the kit inside of a 3D printed refrigerator that we put together. And then a little bit about the challenge. So everything about the challenge is available on this website where we give an overview of the different stages. The GitHub repo that Terrence talked about is available from this page, and it looks like this. And with that, that's our first stage of the challenge. Looking forward to people getting started. Feel free to reach out. We're happy to help any way we can. And with that, we'll open it up to any questions.